solving equations. In mathematics, equations can be thought of like sentences. This equation, 3x minus 11 equals 7, can be thought of like a sentence in English. 11 less than 3 times the number is 7. This equal sign means that these two statements or expressions are equivalent. Therefore, the practice of writing successive equal signs to show steps is incorrect because each equal sign declares that two expressions are equal, and thus each expression must be equal to the very first one. Students may make this mistake when trying to solve this problem by using 6, multiplying by 3, and then subtracting 11 to get the result as 7, as shown. The problem is, the original expression, 3 times 6, is not equal to 7. 3 times 6 minus 11 is equal to 7. But that's not what is shown here. No matter how many equal signs you have, all the expressions involved must be equivalent. Here's a list of things you are allowed to do in order to solve equations or even systems of equations. I will briefly discuss each one. First, you may do the same operation to each expression in the equation. This includes the 4 basic operations, plus any other special operations like powering, rooting, using logarithms, taking limits, etc. Also, you can substitute known values or expressions to simplify the equation, like getting it in terms of a single variable. You can add equivalent equations as in a system of equations. You can also combine any like terms or reduce any fractions in either but not necessarily both expressions. Finally, you can switch the places of the expressions, but this is more for looks, like getting the single variable on the left. In using these rules, we must always ask the same question. Will doing this help me get closer to solving the equation? If the answer is no, there is no need to use the rule. The first thing we will do is solve equations that involve a single variable quantity. This means that the result will always be an equation stating that the variable is equal to a number. Take our previous example, 3x minus 11 equals 7. To solve it, we will use equivalent equations. To get the equivalent equations, we will use the rules from the previous slide. Our goal is to end up with an equation where x is equal to a number. To do this, we will do operations to both expressions in the equation and then simplify. The expression 3x equals 18 is equivalent to the original equation because 18 minus 11 is equal to 7. The way we show what we did can be different. We can show that each expression had 11 added to it like this, or like this. Any one of these 3 would be acceptable in a math classroom, unless a teacher has a specific method that they would like you to use. Now we need another equivalent equation to solve. Since 3 times 6 equals 18, then x equals 6. We can find each expression by dividing by 3, like this. Therefore, 6 is the correct x. I can make sure by substituting 6 into the original expression and simplifying. Showing your work provides a roadmap for you to look at when confronted with similar problems, and it shares your thinking with the teacher so they can see how you got your answer. Before we get into equations with more than one variable, we should talk about combining like terms, because there are many times when we must do this to simplify expressions and ultimately solve equations. Combine means addition or subtraction, so this only applies to adding or subtracting. Like terms always have the same variables raised to the same power. So the first two are not like terms because they have different variables. The next two are also not like terms because even though they have the same variable x, it is raised to different powers. Constants, or numbers without variables, can always be combined with other constants, but not with terms that contain variables. So the third set is also not like terms. To combine like terms, you add the coefficients, the numbers in front of the variables, together. Terms may have multiple variables, but as long as the terms have the same variables all raised to the same power, you can combine them. We usually encounter equations with more than one variable when we deal with formulas. Formulas are designed to have certain values substituted in to find a specific value. However, there are times when it becomes useful to solve formula equations for other variables. Take the distance, rate, time formula. If you wanted to solve for rate, you divide both sides by t. Because distance over time is always the rate. They're not all that easy. Take the Fahrenheit-Celsius formula, currently solved for Celsius. This means if I substitute a Fahrenheit temperature value for F in the equation, I can find out what the equivalent Celsius temperature is. But what if I'm in Europe and I want to know what the Fahrenheit temperature is, knowing a Celsius temperature? Well, we can solve this formula equation for F to find out. Since C equals 5/9 times the quantity F minus 32, the value of F minus 32 must be C divided by 5/9. Using my fraction skills, I know that I can take a reciprocal and multiply instead. Now, 9/5 C is equal to F minus 32. Finally, F must be equal to 9/5 C plus 32. Switching the expressions so that F is on the left, the result is F equals 9/5 C plus 32. problems get more complex, the process is still the same. Do things to get the answer you want. What radius is needed for a cylinder with a given volume and height? Solving this equation for R gives us the answer. Divide by pi h. Now you must square root it all. The result is R is the square root of V over pi h. To get this general linear equation into slope-intercept form, we must solve for y. The result will give me a slope and an intercept. Subtract the whole term ax. Then divide by b. Thanks for watching, and we'll see you next time.